So in this video, we are going to use R and RStudio to forecast a data set that has a level and a trend. We're going to use two files. The first file is datatrend.csv. That is the observed data we have, our historical data, which we'll read in. And the second is forecastkingsexample.r. And so it's always good to kind of see what's going on with your data. So when you first pull up that open, if you open the CSV, mine opened in Excel or wherever you want to open it, you can see in this data file, all it simply is it has a header, demand trend, and then it has a bunch of pieces of data. And you can see it has 104 pieces of data. We end at 762. And so we need to read this in. It's always good to make sure you're reading in everything you want to kind of double check that in R. So let's get started. So if I go and open R and RStudio and I open the file forecast kings example, and if you get started, we will make sure we know where the file location is. So that's at the beginning, and I'm gonna run that stuff. And then if you want, you can run the stuff ahead, but I'm just gonna jump down to where we have that new data set. So I'm gonna now run this file or this line. And the key thing here is because I have my file location already set above here, so that's where I saved all my stuff. The only thing it's going and doing is finding this new file, .csv. And you can notice I have skipped 0 because I don't want to skip anything. I want all the data that's in there. And let's make sure that that's capturing what we actually want it to. So I'm going to run it. And I'm going to print it out. And if I go here, it says demand trend. It starts at 208. And if I look all the way down, it goes to 762. It's useful to kind of check, make sure that's actually what's going on. Okay, demand trend, it goes all the way to 762. Okay, cool. And the key thing there that I did change from the one above is, we're not skipping anything and we're just reading in a CSV file. Okay, cool. So we printed that out. As you can see here, we also have it over here. If you want to go check it out, you can also check it out over there. All right, so again, we're going to do exponential smoothing with a trend, and that is a time series forecasting. So we need to make the data into a time series. So this is just going to add an x-axis to my data. So by running that, the only thing that changed is now I have like an x-axis, right? I have 1, 2, so I now have an x-axis. It's a data structure thing. And we now, can have that information. You can see up here, it also has a time series from 1 to 104 with a frequency of 1. And I'm gonna just plot that. And so if I run and plot that, you can see over here, this data set clearly has a trend, right? It's going up. There's also some error. Remember, all time series data has a level. We could take the average of that. And so our systematic components here are level and trend. So an appropriate time series forecasting methodology would be exponential smoothing with a trend. So let's do that. And so the beauty of exponential smoothing with a trend in R is that it's really quite easy. So this is the same Holt-Winters function we use for simple exponential smoothing. The only change here is we've turned beta on. Okay, so we no longer have beta equals false. And so if you don't remember from before, we can type on the bottom question mark Holt-Winters and hit enter. And guess what comes up over here? And the help tells us about that. And so if we have this, it says, if beta is set to false, it'll do simple exponential smoothing. We don't want that anymore. We want to have beta on as true. And then also but we don't want the seasonal. So we haven't gotten that. So that's why we still need gamma equals false. So if you see here in this one line of code, it does crazy amounts of things. So in some ways, this is a little too powerful, but I'm going to run this one line of code. And now all of a sudden you see up here, we have an exponential smoothing as a list of 9 things. If I click on it, it has a bunch of information. If I double click, I can see what those are. So with that one line of code, it set alpha and beta. So it basically did the step 3, which is create your forecasting model. And it set it that the best alpha and beta are 0.8167 and the best beta is 0.076. And how did we figure out that best beta? It's basically minimizing the one step ahead forecast than the observed data. And this is the sum of squared errors. So this is basically sum of squared errors. If we want the mean, we could divide by how many pieces of data are underneath that. So it's quite powerful. And so we've actually, with that one line of code, created our forecast. But one thing I want to emphasize is we haven't actually forecasted anything into the future. So all we've done so far is look to the past. And so I'm just going to, again, just to kind of get that same information, you can get that same information by using the $sign. So where I put that and I just say exponential smoothing trend and then $sign, it tells you all the things you can get, which are all those things back there. So I'm going to start out with fitted. What does fitted do? Fitted is basically the one step ahead forecast, but because this one has multiple components, you can see this is what's happening. The one step ahead forecast is X hat. But remember, exponential smoothing with a trend has L of t and T of t. And so that's what's happening here. And you can see the other thing that's important to note is this time series does not start until period 3 and it goes to 104. Why does it not start until period 3? Is we need to initialize and do some things. So we have basically a one step ahead forecast starting in period 3 and going up until period 104. Okay. And if I output then the alpha and beta in this, this just gives me my best value for alpha, beta. And how did we set that? It basically took changed alpha and beta. That was our decision variable in our nonlinear optimization problem. And it did it in a way to minimize SSE. And so to graphically see what's going on, if I plot this, you can see over here, we basically have this red line, which is our fitted. This is plotting our fitted values. And the black line is our observation. And so what are they trying to do? By changing alpha and beta, you change the red line. And we want to change alpha and beta so that the squared difference between these different points is minimized. And the other thing to note, if you can see here, is the red line does not start until period 3 and it goes to 104. And so what is this over in terms of how many data points are you doing that over? It's going from 103 to 104 and taking that squared value. So again, we have actually not forecasted anything into the future. This is all historical data, but we now have what we need. We have created our forecast. That is, we have values for alpha and beta. So to just get a little bit more detail of what's going on, I'm just going to use this to just grab that first column from my exponential smoothing thing. So what I'm going to do here is I don't want all of these columns. I just want basically the values that are in this red line. So that's X hat. So this line of code is just saying, okay, give me the first column of this 3-column kind of matrix. Okay, so I'm going to do that by here. And if I do that, you see all I'm doing is just getting that one line, and you can kind of validate if you want to see 256, that's this point here. Okay, that's about right. And at the end, we're at 800. That's this point over here. Okay, so all I'm doing is reading in the values that create that red line. And I might want to know, okay, what is the length of that? Like how many points are there? It's hard to figure that out. It might be hard to see that this is actually period 3. So I'm going to just do that by using the length function. And if I run that, there's 102 periods, okay? So how can you figure that out? That's also, you could have done that just by seeing this. You start at 3 and you go to 104. The key thing here is these are inclusive. It includes 3 and it includes 104. So be careful if you subtract 104 minus 3, you have to add 1 to get 102. And that's because both 3 and 104 are included. So that's the trend. Why would you maybe need that is, again, we were given the SSE, but we might want the MSE, the mean squared error. So how to get the mean squared error, it's just divided by 102. And so if we want the mean squared error, I can run that. The SSE is, 84,459, divide by 102, and we get that the MSE is 828. So as a recap, we haven't forecasted anything, but we have created the forecast. And the beauty of creating the forecast, what do we need for exponential smoothing of the trend? We need an alpha and a beta. And again, this one really simple line of code gives us the best alpha and beta that minimizes MSE or equivalently minimizes SSE. In other words, the difference between this red and black line squared. Cool. Okay, so now we have a forecast. Let's actually forecast something into the future. And so that's where we're going to use the forecasting package. So make sure you have that installed. And so if I run this, all I'm doing is I'm taking in my exponential smoothing with a trend, and I'm saying I want to forecast 8 periods out. And then I'm going to plot that. So I'm going to run these. And we get two things happening. Okay, so we now actually have forecasted something in the period into the future. And in fact, there's 8 periods into the future. So that's what's going on in this graph. This black line is our observed data. This is also shown here. So if you see the first period that we don't have anything, the future would be 105. And I forecasted as 777.84. In the next period, I forecasted at 785, 792. What's going on is it's going up. And that's because we have a positive trend. If we look at the last piece of trend data, you can see we have a trend component that's positive. And so into the future, you can see we're going up. And so that is actually happening. And so these are the things that are going up. You can also see that we have what are called prediction confidence intervals. And so if we want an 80% confidence interval, that is this dark gray here. And as we go further out, we're less confident about our forecast. So we have a bigger or wider range. And you know, one reason to point that out is the first law of forecasts are wrong. And so if you would report this or use this in terms of decision making for other supply chain decisions, it would be good to not just take the point forecast, but to consider the uncertainty set. So you have now used R and RStudio to forecast exponential smoothing with a trend.